So I've got several that I definitely want to get to, so you'll see me skip a few, and then uh,
My mic was off the whole time, wasn't it? I am having a bad luck, a little bit of bad luck today. I had the issue with my 11 o'clock class where the screen share didn't share the sound, which is like the third time that happened. And then I just did a whole intro with the mic off. That was completely on me. Ha ha. All right, so I'm just gonna say a lot quicker what I just said before I was doing that. What we're going to go over today is some questions from the final exam review from the interactive one in Math 154. You can see the due dates and everything. Please remember that our final for 154 is on May 3rd. There is no final for MDE 54, just like there have been no graded assignments. You just had to keep up with the homeworks and do something along the way, not nothing, something. And that was how you stayed in here. Please remember that if you pass Math 154, you will also pass MDE 54, and vice versa. If you fail one, you failed the other. Trying to just pick the best things of what I was just saying in there. Remember, you've got a formula sheet for the exam. Oh, it really threw me off. Okay, formula sheet, the final. We will have our last Math 154 and MDE 54 this Wednesday, 2 days from now. So next week, there's no Math 154 because we're taking the exam, and because there's no more material to cover in MDE, there will be no more MDE classes. So again, this Wednesday will be our last MDE. There will be no MDEs next week. There will be no Math 154s next week, with the exception of you taking the final exam and submitting the work in Canvas within 15 minutes. Besides that, your final grades should be posted within 24 hours of the next day, because I have to wait till midnight for everybody to submit. I'll be asleep at that point. So then we go 24 hours from, let's say, the next morning. And then it's just SIS might take another hour or two to process everything. Per usual, if you have any questions, you can email me. But besides that, let's go ahead and get into the final exam review, which I wanted to do a little earlier for this class, just so you've got that material set aside if you want to look at it again and again and again. And then on Wednesday, kind of like we'll be doing a project type idea. Obviously, I'm not giving you any project. I'm just saying a cool project idea, something with Excel. We're going to expand on that in the MDE class as well. But for now, ignore my dog barking. We're going to go ahead and get into the review material.
if we have time, then we'll come back to it before 2:30. Right. So remember that the review that is in My Math that looks like this, that's interactive, where you have some of the questions with view an example or help me solve this. Not every single one of them has it. I know at least 2 don't have it. Actually, let me say at least 1. I'm pretty sure 2 don't have it, but I know at least 1 of them definitely doesn't have it. And then for the chapter 1 through 4 stuff, you have the paper pencil version with only questions and answers and no actual help between. You just needed to use your notes, your previous homework problems, because most of those problems could be found in the previous homework, or at least very similar, and those had to help me solve this stuff. So the distance you drive is proportional, which means if one thing doubles, the other doubles, to the amount of gas used. Now remember, the word proportional by itself is what means if one thing doubles, the other thing doubles. We can throw in other words like inversely proportional, which actually means as one thing doubles, the other halves. Or we could throw extra words in there like it's proportional to the square, and then there's no if one thing doubles, the other doubles, or if one thing halves, the other doubles, or anything like that. It's completely different. And they can vary with square roots, squares, all sorts of other things. But all we said is proportional, so as one thing doubles, the other doubles. So the distance you drive is proportional to the amount of gas used. So this is assuming that we're going to be driving a constant speed. There's not going to be stop and go traffic, no lights, no quick acceleration. We always keep simple assumptions for problems like this. So they say that driving 138 miles uses 6 gallons of gas. Complete parts A through C. Well, the 6 gallons of gas, this one is very obvious that would be 138, right? 6 gallons of gas takes you 138 miles. This is 6 gallons, and that would be 138 miles. Hopefully the 0 makes perfect sense as well. If you use 0 gas, you can go 0 miles. You have to use fuel in order to move. This was another important concept of proportions, that 0 in one thing is 0 in the other thing. And we said that we deal with a ton of proportional things in the real world, in our real lives, after we're done with QR class. But there are certain things that aren't proportional, or that you might think they are, but they're not really, like temperature, or things that have a fixed amount and a variable amount. With that fixed amount being non-zero, that's what causes this to not be 0 and 0, but that's a whole other problem. All right, so the next one, now you might say, oh, okay, well, I need to figure out how many miles I can get per gallon, so I need to do 138 divided by 6, and this is arbitrary. I don't have to do this, but you could. If I did 138 divided by 6, we can see that we can go 23 miles every time we use 1 gallon, because the 138 is miles, the 6 is gallons, so the units would be miles over gallons. So 23 miles per gallon is our fuel consumption rate. Now again, we don't actually need this based on how this table is set up, because the next is a 12 and then an 18. We're just doubling and tripling these values, which means we could just double and triple that 138. So if you double 138, let me make sure I'm in my calculator, 138 times 2, you get 276. And if you triple 138, or if you just add another 138 to that, whichever way you want to do it, you just, every time you add 6 gallons, you add 138 miles. So you could do plus 138, or we could have done 138 times 3. And either way, you still get 414. Now, maybe you didn't do it this way. These are correct. Maybe you said, all right, well, my 23 miles per gallon, then just multiply by the number of gallons, miles per gallon times gallon, you would see everything cancel. If you have miles per gallon, miles, so MI, and then you multiply by something in gallons, the gallons would cancel and you'd be left with miles. Now, of course, you would have to throw the numbers in there, 23 times 6, 23 times 12, or 23 times 18. And guess what 23 times 6 is? It's 138. 23 times 12 is 276. And 23 times 18, you guessed it, is 414. So they're all good. Fantastic. Great, grand, fantastic, wonderful. Then they say represent the relationship between the distance driven D and the gas used G with an equation. And they say the distance you drive is equal to some number times the number of gallons. Well, that was the thing we got when we took the 138 divided by the 6, the 23 miles per gallon. Also the thing I used if I just wanted to multiply the 23 by the 6, the 12, or the 18. So there's our equation. The distance you drive is 23 times the number of gallons. And you can't say it the other way. You can't say the gallons is 23 times the distance. When you get your answer, it wouldn't make sense unless you're driving a semi with 2 billion pounds of concrete in it or something, and you're going 1 mile for every 23 gallons of gas you use. Ooh, that sounds awful. Next up, what is the graph of the equation that represents the relationship between the distance driven D and the gas used G? So it's very important to understand independent versus dependent. The independent is the left side in this table, and independent always goes on the bottom. So gas, 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 those all make sense. What they could have done is have 2 of these answers, or more or less, have distance on the bottom. And while you could certainly make a graph with distance on the bottom and gas on the vertical, it would just be weird to do it that way. All right, so this one looks ridiculously steep. This one looks a little flatter, flatter, and then flatter. And C and D are actually not too far off. It's just this right side has a height that's almost 250. This height is about 150. So let's see. Our gallons are going between 0 and 20, and here they're going between 0 and 18, so that's a good range. And their distance is between 0 and about 400 and some change, so 0 to 500, about the same. So we know they go through the origin. All 4 of these graphs use the origin, so that's not going to help us. I'm going to suggest that the only other point we absolutely need to look at is the last one. That point right there will tell us all, but the others in between could be used as well. 18, 414, that means we're going to go right 18, and we're going to go up 414. So if on this one right here, if we go right 18, that's about here. And then if we go up, let's just say about 400, every one of these marks is 50. So that would be about here, and that's not where the line is going through, so it's not A. This one over here, if we go right 18, and then we're going to go up. So 18 is about here because every mark is 2. That point should have been here, actually, not that one. Just ignore the left one. So right 18 and then up about 400 roughly. So every 2 marks is 50. So here's 500, 450, 400. That actually looks pretty good. I think it's going to be B, but let's before we answer firmly, let's check the others. Go right 18 and up about 400. So that looks wrong. Go right 18 and up about 400. And that looks wrong. So yes, it is B. It's kind of a process of elimination, but we also used logic and reasoning to get there. Now, does this have to be a multiple choice answer? No, I could give you a paper pencil test in theory and then just ask you to draw the graph. But the thing is, the media tends to give you graphs. So that's why it's honestly not the worst thing in the world to give a multiple choice scenario here. All right, let me clear my screen so I can actually answer. And we said it was B. And it looks like we got it right. And there we go. Question 2, short and simple. Plot the ordered pair 8, 7. That's just right 8, up 7. You can click or you can drag around. But if I'm going to go right 8 and then I got to go up 7, that's where the point would be. And that's it. Just don't go right 7 and up 8. You got to get the left, right, and up and down correct. The cost of an airline ticket is proportional to the distance traveled. So no inversely, no square, no other nonsense. So this is just a y equals kx setup, or as one doubles, the other doubles. And it's at a rate of $36 per 100 miles flown. Assume there is a base charge of $75 though. So actually, this is not a 100% proportion problem because there is a fixed cost or initial cost here. So we have a variable cost and a fixed cost. The 36 is the variable amount, which if all we had was the variable amount, then it would be a direct proportion. We could say 100 miles would cost $36, 200 miles would cost $72, 300 miles would cost $108, et cetera, et cetera, et cetera. But with that fixed cost, we can't forget to add 75 each time. So if we go 0 miles, for some reason we bought a plane ticket from Norfolk to Norfolk, they would still in theory charge us $75 just to stare at a screen. I know that sounds silly, but we're going to go with it. So that would be $75. Then if we're going to go 100 miles, we're going to pay the $70 flat fee plus the 36 for the 100 miles. So we're going to go the flat fee plus the 36 for the 100 miles, which would be 111. To go 200 miles, we'll pay $36 twice because 200 is 2 times 100. So that means we'll pay $72 for the distance plus the base charge is $75, being 147. And then if we go 300 miles, we'll pay this $36 3 times because 300 is 3 times 100. So we'll do 3 times 36. That's our variable cost. So $108 for the mileage plus the fixed cost for running the airport and everything of $75. So 183. And everything looks good. Then they say to represent the relationship between cost and distance, and you'll notice that they don't just do a y equals kx in a setup or c equals kd setup. There's a plus a number because we have a variable amount and a fixed amount. So the thing that goes with the variable is the variable amount, the thing that's a per something. So that's the 36 going with the d, which is what we multiply by 1, 2, or 3 in these instances. And then the fixed cost is what we add that doesn't have a variable, so that's the 75. What happened? Oh, I know why. Because this distance is in miles, and this is per 100 miles. So let's just pretend like I did that on purpose. 36 times d, that means if you went 1 mile, you'd pay $36. That's not quite right. We're going $36 for every 100 miles. So we need to do 36 divided by 100, which is obviously 0.36. So that is what this number should be. It's not 36. If it was $36 per mile, this would be 36. But because it's per 100 miles, that means we're really only paying 36 cents per mile. And that should be correct. There we go. See, I didn't pay attention and I got something wrong initially. And finally, what is the graph of the equation? Two of these you can throw out immediately, and that is B and D. You know how I can throw out B and D immediately? Because the number in front of your variable is positive, which means that your line should be going up as you move to the right. These are both moving down as you move to the right. So they are hot trash, you throw them in the garbage. So the only possibility is A or C, and I can immediately throw out A because of this point right here. This is not the origin, this is 0, 75. This point is going through the origin, not 0, let's just say about here, so it can't be A. The only one that's even closely resemblant to what it should be is C. It's not a matter of having to look at two different points and make sure they're anchored correctly. It's just they gave you two answers that were complete garbage and one that you can figure out is garbage because it goes to the origin, and this is not the origin. It would have to be 0, 0. It almost looks like a face in order to go through the origin. So it looks like it's going to be C. That's clear. Close that. Try out C. And we got it right. Good job. Determine which ordered pair satisfies the equation. This is one I'm going to leave to y'all. You're just plugging, You're just plugging the 4 in for the X and then the 7 for the Y and seeing if you get a true or false statement. If that works, then you click it. And then you'll try the 6, -37. You'll plug the 6 in here and the -37 in for the Y and see if you get something that makes sense. And then you'll do it for the last point. You'll do it for the 0 and the 37. And it says select all that satisfies. So they're saying maybe it's one of them, maybe it's two of them, maybe it's three of them, maybe it's none of them. I will tell you it's not all of them for, wow, that was extremely loud. I'm gonna, let's do this. The volume on my computer must have reset. The funny thing is I'm only at 22, but that was really loud. All right, distractions. So again, I'm telling you that for my particular example, it's not all of them, but I'm not gonna give you the actual answer. All right. The decline in per capita beer consumption is shown in the scatter plot. What is the slope of the linear trend line? That's going to be part A. And then for part B, interpret the slope in real world terms by filling in the blanks. So that's something we did many times over back in chapter 5 with a guided activity, if you're my student at least. So what we're given here is a series of actual data, and data involving people does not always match a trend perfectly. Very often we need to do that fixed endpoint method, or the anchored method as I like to call it, or the sum of least squares method, which is what Excel would do for us. So Excel is, we plotted these points in Excel and then we told it to make our line and display the equation, and it thought all that stuff for us. Thank you, Excel, as I always say. What is the slope? Well, remember that for lines, yes, it goes, the thing with the variable is the variable amount, and then the thing without a variable is the fixed amount. But also it's y equals mx plus b, where m is the slope and b is the intercept. So this number right here should be our slope, that negative 0.115. So let's try that out. And you can't forget the negative 0.115. And we got it right. All right, then our slope in this cookie cutter format, the thing is changing by a number of units per some other unit. So what's changing? It's the per capita beer consumption. That's the thing that's changing. It's the title of the graph, the output, the Y. That's the thing that's changing. And it's changing by, well, that's our number, the slope itself, the negative 0.115. And then these are just the two units, the units of the output per input. So the output is in gallons, And then the input, this seems to be years, so let's say years. And actually, if I do per year, based on their graph, will it be right or not? Let's see. Some people think, oh, this is 1980, then 85, then 90, and then 95, so they'll go 5 years. Spoilers, this is wrong for pretty much the exact same reason as why I got the slope wrong in the last problem. This is actually only dealing with every single year. Yes, the graph is representing every 5 years, but the slope itself is based off of every year. So you have to be careful with something like that. They're trying to confuse you. They're trying to mislead you. And there we go. All right. Consider the graph to the right. In words, describe the function shown on the graph. Then find the slope of the graph and express it as a rate of change, a fraction, or decimal. And then briefly discuss the condition under which a linear function is a realistic model for the given situation. So what we have is, we're looking at time versus distance from home. And this is going down. So if 0 hours have gone by where it looks like 100 miles from home, and then some of the points in the middle are kind of hard to see, and I could zoom in if I wanted to make this a little better. And we can see that it looks like here, 7 hours in, we are 0 miles from home. So 0 hours in, we're 100 miles from home, and then 7 hours in, we're 0 miles from home. That's what this graph is telling us. So that's a decrease over time. So the distance from home is not increasing, it's decreasing, so it can't be B or C. It's decreasing. This is a downward slope, so it's decreasing. So according to the function, the distance from home decreases by 7 miles every 100 hours. That sounds really slow, because this says after 7 hours, we're home, it looks like, and then at 0 hours, we were 100 miles away. So A has the right numbers, but they seem backwards. They seem backwards to the units. How about D? According to the function, the distance from home decreases by 100 miles every time we go 7 miles. So this distance dropped from 100 to 0 as we went from 0 to 7 hours. So D sounds like the answer. And there we are. Calculate the slope. Well, you can actually do that by the statement above, 100 miles over 7 hours. And they say to round to the nearest tenth. Or you could call these 2 points, this would be x1, y1, which would be 0, 100. This would be x2, y2, which would be 7, 0. And then we just do the slope formula, which you're supposed to memorize, y2 minus y1 over x2 minus x1. And whichever way you do it, you will get the same answer because you'll end up doing 100 divided by 7. So if we take our 100, which was the miles we drove, the change in the height, the 100 is the change in the height, and then 7 is the change in the distance, but because we're going down, it's going to end up being a negative number. So let me actually go negative 100, because we're losing 100 miles from home over the 7-hour period. And you get negative 14 point, rounded to the nearest tenth, so negative 14.3. So negative 14.3, and then they say miles per hour or hours per mile. Well, hours per mile is a pretty rare unit, so miles per hour. And that's because the 100 in the top was the miles, the 7 in the bottom was hours, so miles over hours. Then part C, briefly discuss the condition under which this linear function is a realistic model. So this was a case where we were 100 miles from home, and we were driving for 7 hours, and eventually we got home. Or maybe we were walking, or maybe we were running, or maybe we were biking. Walking would be very tough to go 14.3 miles an hour. Running is still really tough unless you're Usain Bolt or something like that, and I think that's probably even faster than him. So this is probably on a bike or in really bad traffic or something like that in terms of the actual speed number, or maybe we're just making a lot of pit stops. Maybe we're in, oh, what's that place called? In the Shenandoah Valley. Beautiful, beautiful. It's like 25 miles an hour. It's outside of Front Royal where it starts, where you get in. Doesn't matter. We're taking a really slow scenic drive. That's the point I'm trying to get to. All right, so maybe that's the relative scenario, but select the case in which this could be. It's a good model if speed is not constant for 7 hours. Well, don't we need the speed to be pretty constant? So I'm not going to say A. I'm not going to say A. It is a good model if speed is changing for 2 hours and then afterward is constant. I don't know. I feel like we need to be going the same speed, the exact same speed the whole time for this to be consistent. Otherwise, we'd have dots, a little higher and a little lower and a little higher and a little lower, which again would be much more realistic with traffic and stoplights and stuff. It is a good model if the speed is constant for 7 hours. Ooh, I'm liking the sound of that. And then if it is a good model if speed is constant for 2 hours and afterward it is changing. I don't know why they have this whole 2 hours and then constant or 2 hours and then changing, vice versa. B and D are absolutely not it. This is a great model as long as our speed is never changing, as long as our speed is constant. And again, you can approximate things in the real world, but the model wouldn't be exact. Like I said, you'd have a dot maybe a little higher, a little lower, a little higher, a little lower, a little lower, a little lower, a little higher, but then everything would just have a best fit. That's what Excel does for us. That's that linear regression line of best fit. All right. Next up, determine the slope of the line. I just mentioned this equation, and the reason I didn't use the equation in the last one is because I knew this was coming. So that formula, which you are supposed to memorize, y2 minus y1 over x2 minus x1, also known as a rate of change. Excuse me. Rate means fraction, change means subtraction, so it's a fraction of subtractions. And it's always the height over the horizontal. So that's our formula. So if we wanted to label things, this would be x1, y1, x2, and y2. So our slope would be, and you can swap the 2's and the 1's as long as you completely swap them. But I'm not going to. So y2 minus y1, that's -5 minus -1. Watch out for those double negatives because that is a -1. We're subtracting -1 over x2 minus x1, which is 3 minus 3. Minus a negative is a plus, that's -5 plus 1 over 3 minus 3. You got calculators, but you're still supposed to know your signed arithmetic. -5 plus 1 is -4. Different signs, subtract, keep the sign of the larger. 3 minus 3 is 0. And this is not something we talked about too much in this class, but we did mention it briefly at the beginning. Anything divided by 0 is undefined. Please note that if these numbers were backwards, 0 divided by -4 would be 0. You need to know which one of these is 0 and which one of these is undefined. So our answer should be B. The slope is undefined, and we got it right. Undefined means if you graphed this, I can only annotate. If we graph this, let's see, we got 3, -1, that's right, 3 and down 1. So there's the first point. And then 3, -5, 2, 3, 4, 5. This is what the line would look like. Please ignore the fact that I'm just a hair off of that marker. That's 1, 2, 3, -1, -2, -3, -4, -5. This is a vertical line. Quite honestly, we do not study vertical lines in quantitative reasoning very often because we don't have any models that are vertical lines. Vertical lines are much more important for concepts in pre-calc and calc, these things like asymptotes. This is an absolutely boring model. There's nothing we do with it. But it's still perfectly valid for calculating a slope. The final, just like the midterm, has some basic just math questions in addition to much more traditional quantitative reasoning questions. All right. Spoilers, this one will have a much more normal answer, but since I already did a slope, I'm going to save it for y'all to do. And remember, my numbers will be different from your numbers. I believe most everybody's 7, it works out to be undefined or 0. And then this one, it works out to be a non-zero or non-undefined number, but I'm not going to promise that. RNG, or random number generators, make things random. All right. So this person is clearly not a state employee at the same job for 7 years, at least not the state of Virginia. As always, shots fired. A person's annual salary increases by $11,375 over a 7-year period. Find the average rate of change of the salary. So a lot of people think average means add up all the things and divide by the number of things. Well, we weren't given a bunch of different things to add up and divide by. We were just giving a total amount and a period over which that happened. So that just means divide the two things. So take the salary change and divide it by the time that it happened over. So maybe we gained $1,000 the first year, the second year nothing, the third year $3,000, the fourth year another $3,000, the fifth year $375. I don't know, but over the 7 years, you are now making $11,375 more. So all we're going to do is take the 11,375, which was the salary, and divide it by the time. That'll give the average change. Average change. The average rate of change, that is to say, rate of change. So this is a difference that we don't have to subtract, it's just given to us, and then from 2020 to 2027 would be a 7-year difference. So just do that calculation. 11375 divided by 7, boom, 1625. 1625, just pretend I read that, please. $1625 per year. And by the way, actually, I'm going to put the annotate back on. That was 7 years. So it's $1625 per year because the year is in the bottom. So that's a per. Oops, take that off. And there we go. All right, intercepts. We said intercepts are where lines intersect an axis, and the name tells you which one you're intercepting. So an x-intercept is where you cross the x-axis. This would be the x-intercept, but they didn't ask us about that. They asked us about the y-intercept. That's where we cross the y-axis, which is right here. So this point would be the y-intercept. So this is the point we want, and there's no number written there, but it looks like it's about halfway between these markers. This is 0, this is 2, so I would say that's a height of 1. Now, they ask us to type an ordered pair, so I'm going to do this wrong at first. Some people will just say 1. And if you were a pre-calc student, there's actually times where that's all we would type. I had to give several students some partial credit for things like that, and I would do the same in this instance for y'all. Your answer must be in the form of an ordered pair. Make sure it's enclosed in parentheses. So it's not just the 1, it's the 0 as well. This point is actually 0, 1. X, y, left or right 0, up 1. So I can't just do 0, 1 like this either. It's going to be wrong, it's going to be wrong, it's going to be wrong. Make sure it's in parentheses. So we go parentheses 0, 1. You can also use this button to just do it like that. Final check, we got it right. Good. This is one we're going to skip. We've already done a bunch of those little tables. Here we go. Graph the equation. So we're going to make our own graph. I've discussed the several different ways you can do this. I've said that you can use a single point and a slope to rise and run. You can do a couple of different points. I'm going to show you 2 different ways to do this. So the first way is just a table of values. Since this is solved for y, my favorite thing to do is just go 0 and 1 for the x's. So this was my choice. You don't have to use 0 and 1. However, I would stick to numbers between -10 and 10 since that's all we have here. If you plug in 0, you get y equals 3 times 0 minus 5, which is 0 minus 5, which is -5. So that's your first coordinate pair. 0, -5, which will be right here. I'll click that in a few minutes. And if I plug in 1 with x equals 1, that's y equals 3 times 1 minus 5, which is 3 minus 5, which is -2. So that point would be 1 comma -2. So we go right 1 and down 2. And there are the 2 points. And then we would just, MyMathLab does that automatically for us. But I said I want to show you 2 different ways before I get this done. And yeah. Okay, so let's just undo that. Where's the eraser button? Let's erase both these points. All right, back on draw. So or with y equals 3x minus 5, that says the slope is 3, which is 3 over 1, which says wherever you plot a point, you can just go right 1 and up 3 from. And it also says that the b is -5. That's the value of the y-intercept. So we get the point 0, -5, which we already know because we already did it a different way. But if we didn't do it the different way, we would just hope and pray. So this time I'm going to plot the 0, -5, which is the y-intercept. This is my second version of it, which will coincidentally get the same points. It doesn't always get the same points, but this one it will. Then from this point, we'll use the slope to find another point. So I'm going to go right 1 to here, and then I'm going to go up 3, 1, 2, 3, to right here, which is the point 1, -2, which again is coincidentally that one. I get the same exact 2 points, and then I can connect and extend them. And I can find another point by going right 1 and up 3, right 1 up 3, and there would be a point, right 1 up 3, that would be a point, right 1 up 3. I can keep going right 1 and up 3. You never reset to the origin when you're using the slope. But again, the points were 0, -5 and 1, -2. I need to click those, 0, -5 and 1, -2. So 0, -5. Oh, I thought I hit that first. You got to hit your line. There we go. And then 1, -2. There's the line that I drew with my pen earlier, and we got it done. Nice work. All right. Decide whether the following statement makes sense or is clearly true, or does not make sense and is clearly false. Explain your reasoning. I graphed 2 linear functions, and the one with the greater rate of change has the greater slope. This makes sense. According to the definition of linear functions, the initial value is equal to the slope of the graph. Thus, the rate of change does not relate to the slope. Well, this says, makes sense, so true, but this says the one with the greater rate of change had the greater slope. These seem to be contradictory ideas, that the rate of change does not relate to the slope, but this says the one with the greater rate of change has the greater slope. This says they relate, this says they don't, but it says true. So it's definitely not A. This does not make sense. According to the definition, the slope of all linear functions must be the same. No. The slope of all linear functions can be whatever the heck they want to be, whatever the heck they need to be. Also in A, something else that was wrong is the initial value is not the slope of a graph. Slope and initial value are completely independent of each other. So B is trash because slopes of lines can be whatever given the scenario. C, this makes sense. According to the definition, the rate of change is equal to the slope of the graph. Whispering into the mic, something I said earlier. So the greater the rate of change, the greater the slope. C's sounding pretty good, but let's check D just to make sense. This doesn't, I'm sorry, to make sure. This does not make sense. According to the definition, the initial value is equal to the slope. I've already said that the initial value and slope are not the same thing, so that's trash. Thus, the rate of change does not relate to slope. It's literally the exact same statement as A, here and here. It's just one says makes sense and one does not make sense. This is very common in these answers. And sometimes it's one of those two things that would be right, but in this case, neither of those is right because they're spitting out hot trash. Initial value is the slope. No, it's not. C is definitely the answer. We already did one of these, and I discussed it in both ways, so let's move on. Here we go. Use the compound interest formula to determine the accumulated balance after the stated period. $6,000 invested at an APR of 9% for 10 years. It's compounding annually, and they want to know how much we have after 10 years. They already said that. Well, that sounds like one for a formula sheet, which I do not have open, but I can open really quickly. Boom. All right, 8 formulas. Well, this clearly isn't a loan. It's clearly not just converting APR to APY. So the question is, let's narrow it down to these 3 things or these 3 things. The top 3 and the bottom 3 basically go compound annually, compound in times, and then present value needed. Compound annually, compound in times, present value needed / payments needed. So what's the main difference? Well, first of all, these 3 are much more complicated formulas. These are simpler, so you probably just want to think, oh, let me use a simpler one. Well, that's not always true. It's about whether it's a one-time deposit, which are these 3, 3, versus a multiple deposits. Yes, I spelled that wrong. Just go with it. We are not making multiple deposits. So these 3 are out. We are making a one-time deposit. How do I know that? I read the question carefully. We're putting $6,000. It doesn't say $6,000 annually. It doesn't say $6,000 monthly. It doesn't say $6,000 quarterly or daily. It says $6,000. That's a one-time deposit. So we're under one of the top 3 formulas. We're narrowing down. Are we compounding annually or are we compounding in times? Well, we're compounding. It says, where is it? Annually. So that means we definitely don't need to use the second one, but it could still be the third one. You might say, oh, well, compounding annually, so don't use that one. Well, it's a matter of what do we know? The first one is when we know the start, because that's the P, and the third one is for when we know the end, which is the A. We don't know the ending amount, we know the starting amount. So that means this is our formula. The one that I suggested for my students to memorize, even though it's on the formula sheet, because this is just previous balance times growth factor raised to time, which is an extension of previous balance times growth factor. Just that's for 1 year. This one right here is for multiple years. All right, so we're going with A equals P parentheses 1 plus R. Oops. I don't know why I started opening another parentheses to the T. This is our P, this is our R, and this is our T, but make sure that the R is converted to a decimal. So that's $6,000 times 1 plus 0.09 raised to the 10. And that's all we should have to put in our calculator. Alternatively, what you could do is build an Excel spreadsheet really quickly and look at what happens years 1 through 10 with a simple growth factor every year. But it's not exactly what I'm looking for with a test. You're not supposed to be opening Excel for a test. So 6,000 times, and you may have to hit times, I don't have to. And then 1 plus 0.09, close it, raise it to the 10th power. And we get 14,000 and some change dollars. 14,204, we're rounding the nearest cent. So 14,204.18. We got it right. If you can read through that, excellent, check mark, yes. Annotate, clear. All right. This one is very similar, but there is one drastic difference which will cause us to use a different formula. $16,000 is invested. So this is a one-time deposit, so we're under those top three formulas. For 4 years with an R of 4%, and we're compounding daily. This right here means that we have an N, so we don't use the first formula. We're going to use the second formula. Why is this being silly today? I don't want to erase that stuff, actually. I want to erase this. So again, we are compounding daily, so that's out. We know the starting value, so that's out. This is also a no start, by the way. So we'll run this formula. We're not using any of these formulas down here because these would be multiple deposits and we're only making a one-time deposit. So A equals P parentheses 1 plus R over N raised to the NT. So that will be our formula. Let's go to annotate. A equals P parentheses 1 plus R over N raised to the NT. So with this being your P, your T, your R, and the N daily being 365, means we're gaining money every single day for 4 years. It tells us A equals 16 grand, parentheses 1 plus 0.04 over 12 raised to the NT. That's 12 times how many years? 4 years. Now I did say to make sure you pre-multiply your exponents for your calculator. 12 times 4 being 48. So that's what we're going to put in our calculator. So 16,000 times 1 plus 0.04 divided by 12, close the parentheses, raise it to the 48th power. Now, if I got some answer like $10 billion or $5, these would be drastically wrong. You want to make sure your answers make sense. 18,000 and some change, that sounds good. This interest rate isn't super high, the time isn't super high, so I don't expect this to turn into $1 million. I'm not continuing to add to the pile. That would have helped as well. So 18,771 point, that's 0.178, so 18 cents. 18,771, 18. What am I doing wrong? Oh, I know what I did wrong. Why did I do 12? I got sidetracked. This and this are wrong. Those are wrong. We're compounding daily. That's where the N is supposed to be. That was supposed to be 365. So I am so sorry for that. That's wrong. It's supposed to be 16 grand, 1 plus 0.04 over 365, raised to the 365 times 4, which 365 times 4, I just had months stuck in my head for some reason, and I would have gotten that wrong. You know, it will be close. Our answer is not going to be that far off from $18,700. $16,001 plus 0.04 over 365 raised to the 1460. Let's try that out. We'll get the right answer this time, I promise. 16 grand times 1 plus 0.04 divided by 365. Close it, raise it to the 1460. I should have caught that that didn't make sense because if we're compounding daily, we're going to gain interest more than 48 times. We're going to gain interest almost 1,500 times. And look how close that answer is. It's only $5 off. So, I mean, in terms of you being close, you probably won't care in your whole life. But for the math class, you have to be exact. That 0.009 will round up to 1 cent. So let's get it right this time. 18,776.01. Let me clear my screen just so you don't see all that nonsense there. And now we got it right, thankfully. All right, we got time for about 2 or 3 more. Decide whether the following statement makes sense or doesn't make sense, and explain the reasoning. A small town that grows exponentially can become a large city in just a few decades. The statement makes sense because exponential growth leads to repeated doublings, making the population increase slowly. Okay, well, exponential growth does lead to repeated doublings, but that can make the population increase quickly. So it's not A. Can't be A. Doesn't make sense. Can't be that. B. The statement makes sense because exponential growth leads to repeated doublings, making the population increase rapidly. So it's just the contradiction of the first one. Instead of making it increase slowly, increase rapidly. Well, repeated doublings can make the population grow rapidly. Okay, so B might be it. Let's go through the others though. The statement does not make sense because exponential growth cannot continue indefinitely, so the population will not get large enough for the town to be considered a city. So C has some stuff that makes sense that I've tried to hammer out to y'all over and over and over, that exponential growth, especially with population dynamics, doesn't continue forever. It eventually flattens out for basically population cap reasons, that eventually we're going to run out of room. But if you're a small town, are you going to run out of room that quick? I don't know. So C has got some sense to it, but I don't know if that's what they're looking for, right? That's what you're thinking. So it can't grow indefinitely, so the population will not get large enough for the town to be considered a city. I don't know. It's got a part that makes sense, but I think a town could certainly turn into a city over time. I don't know about C. Between B and C right now, I think. The statement does not make sense because exponential growth leads to repeated halvings. Complete trash. Exponential growth leads to repeated doublings. Exponential decay causes halves. You'll half it, half it, half it, which we did skip that guided activity, but I did at least talk about the basic idea. So it's definitely not D. It's definitely not A. We're between B and C. I don't like that part of C necessarily. I know what the answer is, so am I leading you right or wrong? The basic idea here is B, and it is. So my problem with C is it does give you some things that I've emphasized, but the last part doesn't have to be that way. A town can certainly turn into a city. New York City was at some point a town. They have more than 10 million people now, so a town turned into a city. So I really like that answer C in terms of trying to throw you off, and I know that sounds evil because it has a fact that's correct with it, but then also something that's not correct. So you have to check all aspects of these answers. Skipping that one. What is correlation? Give 3 examples of pairs of variables that are correlated. A correlation is only when 2 variables tend to increase or decrease together. A correlation exists between 2 variables when higher values of one consistently go with higher or lower values with another. Correlation is only when 2 variables tend to change in opposite directions, or a correlation is when one variable causes another variable. So that chapter 8 stuff, I hammered out correlation versus causation. Causation means one causes another. Correlation is they happen to move in the same way or in opposite ways consistently, but it's not necessarily because one causes the other, like the whole pirates don't actually cause global warming, but the number of pirates went down while global warming went up. So it's definitely not D. It's not D. The others, a correlation is only when variables tend to increase or decrease together. Maybe that's it. A correlation exists between 2 variables when higher values of one consistently go with higher or lower values of another. Correlation is when 2 variables tend to change in opposite directions. C is not the answer. I can tell you that much because they can both go up, or one can go up and the other can go down. So the pirate example, pirates went down, pirate population, and global temperatures went up. So that's an opposite correlation. But it can also be correlation with, as you sell more apples, you make more money. So they both go up. So correlation they can both go up, they can both go down, or they can go in opposite directions. So C is only half right. So let's see. Is it A or B? B. Two variables with higher values of one consistently go with higher or lower values of another. That sounds like it could go either way. Correlation is only when two variables tend to increase or decrease together. So A actually sounds like C in that if one goes up, the other goes up, or if one goes down, the other goes down. It's not allowing one to go up and then the other to go down. So let's try B. And we got it right. Give 3 examples of pairs of variables that are correlated. Production cost of movies and gross receipts of movies. So does the cost reflect the money coming in for it? Per capita personal income and the percent of the population below poverty level, and then height and weight of people. Height and weight sounds good. Percent of population per below poverty level versus per capita personal income. Well, that would be an inverse correlation maybe. So A is a maybe, but I don't know about that first one. Just because you have a high costing movie, does that mean you're going to get more money off of it? There's plenty of movies that might argue with that. All right, amount of smoking. I just combined smoking and lung somehow with smoking. Oh boy, that's a weird sounding word. Amount of smoking and lung cancer. So the more you smoke, the more lung cancer you get maybe. Height and weight of people. So we liked that one before. The taller you are, the more you might weigh. The price of a good and the demand for a good. So if you bump up the price, does demand go up? Well, no, I think if you bump up the price, demand would go down. I'm kind of liking the sound of B so far. All right. C, the Super Bowl winner and the performance of the stock market. So that kind of sounds like pirates and the weather, right? Amount of smoking and lung cancer. Well, we liked that one for correlation. Per capita personal income and the percent of population below poverty level. So I kind of like the last two, but Super Bowl winner and the stock market, I don't know if the stock's going up because the Super Bowl winner was picked accurately or because one team won versus the other, or the stock market goes down because Dallas won. It just sounds weird, right? It doesn't really make sense. Could they correlate? Maybe, but I'm not liking it. Production cost of movies and gross receipts of movies. We already said we don't really like that one. Inflation and unemployment. I've given you inflation charts before. Go to the internet and pull up an unemployment chart, and you might not see too much correlation there. Super Bowl and stock, wow, this one just sounds like complete trash. D sounds like the worst of them all. The only one that seemed to have 3 good ones was smoking versus lung cancer, height versus weight, price of good versus demand. I'm liking that one. That would be my choice. And we got it. Last one, and we'll call it a day, we'll call it a semester. And remember, for this MDE 4, this is it. You don't have any tests, you don't have any homework. You're just here. Hopefully you've been doing the homework assignments. I'm speaking to myself here, but I've got to find a way to influence students to do more of the homework. 2 or 3 of you did a good job for a while. And at the same time, we also suggested that if you were kicking butt in the Math 154 course, it's not the end of the world if you stop with the MDE 54 stuff. So my students making B's and C's in 154, I'm not mad about you not doing work in MDE. But the students who didn't make A's, B's, or C's in 154 and you're still hanging out in MDE and you haven't been doing your work, maybe you should have been doing more work. And again, this is just, I've got to find a way in the future. I've got to find someone to change the system, basically. I want to be able to force y'all to do homework, and I can't right now, and that sounds really, really contrary to a normal class, but this isn't a normal class, as you know. All right. Define and distinguish among positive, negative, and no correlation. How do we determine strength of correlation? So first of all, positive correlation means if one goes up, the other goes up. So positive correlations means that both variables tend to increase or decrease together. Sounds good to me. That's weird. Usually it just continues automatically. Define negative correlation. This is when they go opposite directions. So negative correlations mean that both variables tend to increase or decrease together. No, we said that was positive, so it's not A. Negative means there's no apparent relationship. That's no. That just means there's no correlation. Negative correlation means there's a bad relationship. That would just be weak correlation. Negative correlation means the 2 variables tend to change in opposite directions with one increasing and the other decreasing. Boom, there's our answer. Define no correlation. Means the two variables are always zero? Absolutely not. No apparent relationship between the variables. Ooh, that sounds good. They tend to change in opposite directions. Well, we already said that's negative. Tend to increase or decrease together. We already said that's positive. No correlation means no relationship. Weak correlation would be weak relationship. And there we are. So basically same thing I said for my Math 154 students. It's been a pleasure to teach y'all. I hope you've been able to learn and understand, and I hope that something from this MDE course has helped you. I would actually love if you emailed me, and if you don't want to, understand, but I would love if you emailed me and gave me some positives about this course, maybe even give me some negatives, what you would have liked to have gotten out of this. This is the first time we've done this MDE 54 course. I'm always looking for feedback. You know what they say, if you don't change, you're a dinosaur. So for the next time I teach this, if there's things that I need to improve upon, I would love to know that. So again, just please give me some feedback in the email. Tell me if you like this. Tell me if it was helpful, anything like that. So besides that, have a good rest of the semester. Good luck on your finals.
And just as a reminder that we will have class on Wednesday. Like I said, we'll just do something a little more off the wall, like a project idea. So study, study, study. Email me with any questions, and take care, everybody.